The next topic is about the meaning of solution. Solution and initial value problem. Like I said, for differential equation, you got to put the boundary condition whenever you want to find a solution. But for this one, I'm going to talk about the initial value problem, like initial boundary condition, something like that. Okay? And for the solution, what I meant the solution is the answer of the differential equation. Okay, not the solution that when we're talking about the chemical things. Yeah, this solution means the answer of the differential equation. In general, we can divide into two different types of solutions. The first one is called explicit solution. The explicit solution is just the answer that satisfies the differential equation with all x in the interval I is the integer. Okay. Let me give you example of explicit solution. I said that they have two types of solutions. One is explicit solution, the other one we call implicit solution. Okay, I will tell you what the difference. But when we talk about the meaning, sometimes it's kind of not clear. But if you look at the example, it might be more clear for you to distinguish between implicit and explicit. Okay? The first example for the explicit solution, like if I have the c, 3x is equal to x squared minus x to the power of negative 1. I said that show that this function is an explicit solution for the linear equation. This equation. This one, the linear equation, isn't it? Is it a linear differential equation? Yes, it is order 2 with a degree 1. Yeah. So the way that we do is just that we just put this function into this equation and see whether it is the answer. If it is the answer, then when you put it in here, you would end up with 0. Okay. If this is the answer for this equation, when you plug this one in this equation, you would get 0. But if this is not the answer, when you plug it in, you would end up with some number or some function which is not equal to 0. Okay. So the way to show it, you just plug this in. So this one is say phi is equal, actually it's a y is equal to x squared minus x to the power negative 1. So just put phi as a y. So in this case, you got to dip phi how many times? 2 times, because this one is that the second derivative of y. Yeah. So do the derivative of phi to the x, because x is the independent variable. The first time you dip it, you will get the first derivative is right, and because the derivative itself has the property of distribution, so you can just distribute each term. You would get dx squared by dx minus dx to the power negative 1 by dx. You did x squared by dx, what you get? 2x. You do differentiate of the x to the power negative 1, what you get? 1 plus 1 over x squared, right? Which is equal to this one, right? And then you do it again one more time. This would equal to d 2x plus 1 over x squared I dx, which is equal to d 2x by dx plus d by dx of 1 over x squared. So the first term what you got? 2. And the second term you got negative 2 over to the x to the power 3, which is this one, right? And then what you got to do is just plug this one in there. So you would get 2 minus 2 over x to the power 3 minus 2 over x squared times x squared minus x to the power negative 1. If it is equal to 0, that means this function is the answer of the equation. Okay? So, this is 0. 2 minus 2 over x to the power 3 minus 2 plus 2 to x power 3. This is equal to 0. 2 minus 2, done. Negative 2 over x to the power 3 plus 2 over x to the power 3. So they are equal 0. So that means this is exactly the answer of this equation. And it is explicit because x could be any number. Right? X could be any number and make this function to be the answer of this equation. So it's really explicit. The meaning itself explicit, it means that it's the answer of the equation. It's just only one answer for the equation. The second example show that for any choice of the constant c1 and c2, the function c is equal to c1 e to the exponential of negative x plus c2 times exponential x is an explicit solution to the linear equation, to this equation. This one is also the ordinary differential equation, and this is the linear differential equation with the order of 2, right? And the way you do it, just try to put cx into the equation and to see whether it is the answer. If it is the answer, then you would end up with 0. That means it's really the answer of this equation. So the way you do it is step 3 2 times again, because this is the second order, the second derivative of y by x, right? So I put this c x to x. Okay, using this distribution property. Because c is a constant, so we can take it out from the derivative side. Derivative of the exponential of minus x is equal to negative, right? Negative e exponential of negative x. And differential of exponential of x is equal to exponential of x, so we move it out with this. We do it one more time because the problem statement itself says that the highest order of this differential equation is the second. So you difficult to do some one more time. Again, using the distribution property of differential. So you will get C1 is exponential of negative x plus C2 exponential of x, and then you just plug this and then back into the equation, the differential equation. You would get this. Is it equal to 0? You see C1. What did I do wrong? Oh, this is negative, right? So you would get C1 exponential of negative x. This one minus minus equal to plus, then you get C1 exponential of a negative x. So this term and this term, you can sum them together. You would get 2C1 exponential times exponential of negative x. And this one you have negative 2C1 exponential of negative x. So they all cancel out, so you would end up with 0. This means that with the phi equal to C1 times the exponential of negative x plus C2 times exponential of x is an explicit solution of this equation because we have only one solution for that. And C1, C2 can be any number depending on the boundary condition that you give. อะไรคะ Really? Oh, นั่นดิ C2 just a sec